we might get ourselves underway then. Well, I'm John Grundy, as probably you can tell by the Zoom label. I thought of putting some facetious name on, but I decided not to. My hastily cribbed together background is this is the MOBILESoft 2020 panel. Thanks to David and the other organising team members for having been willing to have a panel again. We had a panel last year, which I also co-chaired. It was pretty good actually. We actually struggled to finish. People had lots of interesting stuff to talk about, and it spurred a lot of interesting discussions. So again, while we're doing this in a very, very different circumstance, I'm quite hopeful that again we might spur again some interesting discussion, not only during the panel but maybe after it as well. I might. Sorry, David, you want to go ahead? Yep, go for it.
Sorry, John, if I just may add, like the session will be recorded, and we will just record those whose video is on. So according to follow GDPR rule, we need to inform everybody that if you turn on your video, you'll be part of the recording and you'll be put on YouTube. So if you prefer not to have your video to be shown, just turn off your video and just be gonna also only capture everyone whose video is on. Yes.
Thanks for that. So whoever's got control, if they can push the button, you'll get a thing pop up. Oh, it is recording. Oh, is it still recording? Oh, okay, good. Okay, so people are being recorded. If you don't like that, time to leave, I guess, is the issue. Alrighty, so we have 5 panelists today. What I'm going to do is, in a moment, get each of them just to very briefly introduce themselves and their background. We've got some hardcore mobile developers. We've got some hardcore mobile researchers. We've got some that are both. And I've also got a panelist, I guess, who hasn't done so much work applying things to mobile, but I think bring a very interesting view of things we might want to do more of in the mobile software development domain. But I just wanted to start off with a motivation. So I mentioned somewhat facetiously on the chat, on the Slack this morning, I've got this COVID-19 app we use for tracking in Australia. And you would think that after all the effort we've put into research and development of mobile apps, so we could come up with a good mobile app for this kind of thing, a really critical thing. But it's got a bunch of problems. First of all, the interface is actually really difficult. It's actually difficult to install before you even get the thing going. Then you've got to go through some screens and stuff to say okay to various things and so on, but it's not very intuitive. Then it crashes periodically. I've no idea why. There's probably I've got an iPhone that it's running on. I've got no idea why it's crashing. I haven't bothered to try and diagnose it, but it's obviously not the most stable thing in the world. It uses Bluetooth technology to figure out who else you're in contact with. So the idea is you can then, after the fact, figure out, well, this person's come down with COVID-19. We've got to find everyone else that's been around in the last 2 weeks and stick them in isolation and test them, blah, blah, blah. But unfortunately, it's incredibly resource hungry, so it drains my battery of my phone. I never have it on unless I go out. So obviously around home, it's not terribly useful. I know exactly who I'm in contact with. But when you go out, the idea is when you get in proximity to people. But it's very resource hungry. And then getting rid of it. So I tried to actually get rid of the thing. And again, that's not actually the easiest thing in the world to do either. One would think you could erase the thing off the face of the phone, but it's not. And finally, there's been a huge saga about security and privacy issues. This is brought in. So to me, when we think about engineering mobile apps, why can't we, given the crisis the world is facing at the moment, design and develop and deploy highly efficient, effective, and useful set of apps for supporting us, not just in, say, this kind of tracing thing, but other kind of things, this remote working and so on, remote teaching, etc., remote living, that we've all had to adapt to very quickly. That kind of brings us to the kind of focus of our panel. What are the current challenges in engineering apps? And I'll suggest a few of them right now, but there's probably many more our panelists will flag. How are we going to tackle those? How are we going to improve the engineering of apps? What are our key future challenges? We as a community, and I would hope at MOBILESoft we're kind of leaders of this software engineering of mobile applications community. How are we going to improve things in the future? So without further ado, I'll run through the panel. So I might do it just in the order they're turning up in my chat thing here. So give us a brief intro of yourself.
Okay. Hello everyone. My name is Patanamon Thongtanunam. So I'm a lecturer at the University of Melbourne. And so my research goal is about to improve the developer collaboration practices. So basically, I want to know how they should do and what are the management policy that enable them to achieve the high quality of software, especially in the rapid pace of the mobile software development. So, and my recent work is more focused on code reviews, which is one of the collaboration intensive practices. And so I just have my recent work at GSE, which highlight the evidence of potential bias, like giving approval without comments during the code review. And also I highlight some impact on the software qualities. So basically, I want to highlight that not about the technical part of the software development, but we also should focus on the developer collaboration and the development practices. Yeah, thank you.
Brilliant. Next on my list is Scott.
Hey everyone. I actually did my PhD in mobile app architecture with Grundy. And we built a little tool to generate apps that addressed many of the core concerns which John touched on in his introduction. These days I work at the Deakin Artificial Intelligence Institute, where I work closely with industry with a focus on ML projects. And recently I was involved in both the development and the design of an e-health application to help monitor patients who tested positive to the coronavirus. I've also got a PhD student that's investigating how to consolidate the many e-health applications around and try and improve the usability of these systems.
Thanks, Scott. And also I'll just mention that Scott had a little sojourn between his PhD finishing and his becoming a senior research engineer, where he worked in industry, leading a team developing various apps and other kind of software. Then decided to come back to the I guess research side of the equation. Next in my list is Mattia.
Hi everyone, my name is Mattia. I'm an assistant professor at University of Minnesota. And the goal of my research is to improve software quality through testing and maintenance techniques. A lot of my research has been focusing in the domain of mobile apps. I've done research on mobile testing, compatibility, identification, and then bug reporting and studying and evolving mobile apps as well.
Thanks heaps for that. And Christine.
I'm Christine. I'm a professor at the University of Texas at Austin. My research is kind of at the intersection of kind of mobile software engineering, but on the networking side. So I look at kind of when you take like abstract, like network protocols, how do you abstract them and make it easier to develop software around them so that you can keep mobile devices connected to each other. John's introduction makes me very nervous because I got tapped as part of the team to develop UT's reopening app, and we launched our beta today. So if I look unrested, there's reasons there. The reason I was tapped for that was to do our on-campus Bluetooth-based contact tracing. So all the things that John's talking about, privacy and energy efficiency of that, have been at the forefront of my mind for the last couple of months. So. And I'm not usually the person who does that. So I think when John had his thing on, he said we have hardcore researchers and we've got actual developers. I'm really on the hardcore researcher side. So it's also not a hat I usually wear. So that's been really interesting. So unfortunately, in preparing for the panel, I think that experience has colored some of my answers. So that'll be unexpected.
No worries. Excellent. We did have another panelist, Mario. I can't see him in the list anywhere. So I don't know if he's got his time zones mixed up, is asleep, or what's happened. But if he joins us, I'll toss him in the mix, as one does. So I'm going to start off with asking each of the panelists again to make a short statement about what they think the three, or they don't have to use three, but something around that number, key challenges are. Then we'll open it for audience questions or comments on the panel statements. Now, panel members, feel free to be as bold as you feel like, or even, dare I suggest, as controversial as you feel like. If someone else says they think this is a top challenge and you disagree, again, you can say something to that effect, and then again in the discussion phase we'll try and tease it out with the audience as well. So actually, reverse it around and say, Christine, tell us your top three.
goodness. Okay. So my top three are, the first one actually is kind of the ecosystem around developing a mobile app. So we do tend to, these are challenges in kind of mobile app development. We think about writing the code, we think about the architecture, all that stuff we were kind of taught to do, but we forget about kind of the social engineering aspects of it. We talked about, I mean, John was mentioning UX. I think testing, we know we're supposed to test, but we always forget to allocate resources, where the most important resource of that is time. And so it's kind of, to me, that one big challenge is that all that other stuff that goes around an app that's beyond what we generally are thinking about. And I think it's important to allocate time. So that's my first one. The second one is, what I've done research on. So it's self-serving for me to say this is one of our big challenges. It's what I've done research on for the past 15 years or whatever, which is kind of the adaptivity of those applications. How do they respond to the context that they're in, whether that context is like changing location or the situation or activity of the user? How do you make sure the application is really being responsive to that? So that's sensing, it's communication, it's computation, it's user interface, it's all of that wrapped into one. And then I've been thinking more recently kind of also about that adaptivity in the long term. Like, how do you design an app in such a way that it adapts to a user's changing situation over a long period of time to keep a user engaged and persisting in the app for kind of a longevity thing. So adaptivity is my second one. And my third one, I didn't say in my introduction, but I've started wearing a hat of, I'm a diversity officer for my college at UT. And I've also started doing some work with app deployment into a lower socioeconomic neighborhood with the school district here in Austin. And so equity's actually become a really big issue for me in mobile app development. So we develop apps thinking that everybody has the latest smartphone with all of the bells and whistles, because we're thinking like researchers 5 years out, like we're thinking about kind of what's the research on the horizon, and we're leaving huge swaths of people behind when we do that. So how to think about kind of bringing everybody in, making sure that, touch tone phone apps are supported and integrated with like this COVID-19 app that we're building. When you think about mobile apps in a smart city, how do you make sure that everybody, even if they have, a 5-year-old phone, can participate? So I think there's that equity aspect. That's my third one. So I'm going to summarize because I talk fast. The ecosystem of mobile software engineering, adaptivity of applications, both short and long term, and equity in app deployment.
Great challenges, Christine. Thanks so much. I'm just going by my window order here. Scott, give us your three or some subsection of three.
All right, so my three are similar to what Christine said, but perhaps from the more technical and the engineering perspective. So the first one that really hits home to me, which is a bit of a surprise, is the privacy considerations that continually to be ramped and violated by clients. So Apple iOS 14 recently put out a version that allowed them to detect when apps were detecting and copying content from a clipboard. And they found a whole bunch of apps that were collecting it. Like, I'm not sure if a social media video sharing app really needs to know what I'm copying and pasting on my phone. Now, the challenge isn't that people are doing that, because they can. The problem I have is that there's no evidence or proof to the user that they can that what the people are actually doing with that is sensible or knowledgeable. So one of the vendors indicated and said, look, we're not storing the content, we're not doing anything bad with it, and we've put in a fix. So the only proof that anyone's got of this is through the app store vendors, iOS or Google, saying, yes, that's correct. So to me, it's like at the architectural level, there's no fundamental way, no provenance chain, no proof of people being sensible with the data that we give. So apps are basically black holes for data. The other thing, the next concern I have is more of a nuanced approach to Android apps. So the work that I've been doing when I was studying apps started around maybe 6-7 years ago. And we've still got some of the same problems that happen now. We still have apps that crash. I still have apps that I have to turn off and on again before they work. And I think it comes down to the nuances and the characteristics of apps, and not any individual concern, but the combination. So we have sensors, we have a variety of sensors and sensing devices. We have the protocols that Christine alluded to. We have hardware capabilities. And it's the intersection between these constructs that developers have to deal with. There's also a concurrency model that's unique to a mobile application. And there's this influence of the ecosystem that influences the way that developers have to build their systems. So frequent updates, changing privacy permissions, changing APIs. In the case of Android, different applications can, or different vendors can actually modify the underlying APIs. It's this combination of factors which I believe causes some of these problems. All right, and in my third one, I want to touch on a much broader integration. And I think this is going to be a problem that grows, and that's the integration of the mobile app into the wider cyber-physical system that it's integrating with. Rarely does a mobile app live in isolation. It always connects or communicates with other devices and other protocols. And back to the engineering focus, the change in nuances between switching between, say, Bluetooth and Wi-Fi and integrating with other devices and dealing with the compatibility issues at that level. And just one last point on this is that there's also sort of three broad approaches that apps can use. They configure other devices like Google Home or Amazon Alexa. They control and monitor the homes and the environments that we're in. And they also interface with the IoT devices. So dealing with all the nuances at every tech stack integration protocol is quite a diverse challenge.
Cool, excellent. Mattia, you're next to my picture list.
So two of the points were already touched by Scott and Christine. And I will start with the first one, which is at the top of my list. It's the fragmentation of the mobile ecosystem. So this, it's very true for the Android platform, and it's becoming true also for the iPhone, so mobile iOS platform. And so you really have that the platform evolves so quickly, and developers really struggle to keep up with this evolution. And actually, there was an interesting paper today from the Software Development and Evolution track that presented that for 6 years ago, when a new version was released, 70% of the apps were ready for that release. But right now, only 5% of the apps are ready. Why is that? Why it's becoming worse? Is it more difficult to port? And so also the work we have done, probably, I mean, how we can help making this better. So that's my first point. And that's about the evolution of the framework. But as Scott mentioned, you also have the vendors modify the operating system. So you also have a device incompatibility. So the same app running on two different phones behave differently. So what can we do to improve that? So that's a critical point. And then second, it's about bug reporting. So we always mention about bug, and I believe that the mobile ecosystem is very unique framework, because people are really willing to tell you when something crashes. So if you think about desktop systems, we don't have such rich information from users. Users tend to maybe ignore crashes on their desktop environment. But in a mobile system, people are pretty vocal. So what can we do to elicit the right information so that we can quickly fix the bugs that are in the field? And then finally, it's related about what Christine said, that these apps run in a very specific context. So their behavior, it's in different contexts that might be different. So how do we enable testing in such different contexts? And here I see a two-phase problem. One is how do we capture the data on which we want to test? And second, how do we enable testing in such type of context-aware environment? And so those are the three main challenges, which I will summarize. First is fragmentation of the ecosystem, what we can do to deal with that. Second, bug reporting. You have functional, not functional, or issue-centric type of problems. And also you have testing in a more context-aware environment.
Excellent. And Pick.
Okay, actually I have a similar thought as Mattia, but I'm more focused on the mining software repository, I think. So the challenge that I'm interested is about how can we identify the bug reports in the mobile apps, because it's not like the open source projects that they have a bug report repository and like we can easily mine everything and see what the bugs is. But for the mobile apps, most of the bug reports are in the user reviews and lots of user complain, and everyone can see that complaints. And how can we identify those bugs and then how can we fix that? And the next challenge is once we identify the bugs in the user reviews, then how can we localize it? How can we know that, how can we fix and how can we solve the issue quickly to make the users satisfied? Yeah.
Right. So thanks very much, panel. What I'll do now is if anyone wants to ask a question or make a comment or disagree or agree, there's a raise your hand thing in the Zoom, which hopefully you can see. And if you look under participants, if you stick that up, I'll be able to call you out to ask a question, make a comment, agree, disagree. Anyone would like to do that? Aha. Oh, hold on, Christine's doing one. Go ahead, Christine.
I was curious when it was Mattia said that people are really willing to write bug reports. And it made me wonder, it's kind of like students and grades. I wonder if you get certain bug reports from certain kinds of people and not from other kinds of people. So I have a question for John. John, have you reported the bugs that you've experienced with the COVID-19 app?
Excellent question. In fact, I have two students working on app review and other kind of mobile app development related, bug reporting and so on projects. But no, I have not. And I'll tell you why. Because it's bloody difficult to report those things to the development team to do something about it. We actually are doing an analysis of a number of COVID-19 apps from around the world in another project. And in fact, Mattia and I have been discussing yet another project along similar lines, particularly looking at the defect reporting, whether it be through app reviews, through an issue tracking system, through some sort of dialogue process, and so on. But some problems are much more difficult to report than others, of course. And some issues, again, I think developers don't see them as issues the same way users see them as issues. So I still think there's a them and us gulf between those of us who design, develop, deploy apps and those of us who use the apps.
So my point was actually, I wonder if we, our current bug reporting mechanisms for mobile apps actually elicit the right set of bugs.
Yeah.
The important bugs. And I don't know how we know, but when you said that, Mattia, that's what that crossed my mind almost immediately, was whether we just
there's also the problem of, again, repeatability and so on as well. So, all the different platforms, versions of hardware that people have, the other apps that are running with them. I think Scott also touched upon, apps that talk to other apps or talk to features and, potentially interfere with each other and so on. It's an interesting ecosystem to repeat when you're trying to diagnose and fix. Anyone from the audience got a hand up? I haven't actually seen any. It doesn't mean that they don't.
Can I
add
a little bit?
Oh, go ahead, Peg. Yep.
Yeah, just want to add your previous discussion. I just feel that when the user report the bugs in a user review, it's not like the technical bug report, like the issue tracking system, because the user is not a technical person, and usually when they complain, there is an emotion in that, and it's very hard for the developers to know, is this the real bugs or this is like just frustration that they have and then they complain and the developers don't know how to fix that. So I think it's very challenging for the developers to know what's the real bug in there. Yeah.
Another interesting factor on this defect or the bug reports is I think it depends on the type of developer who's receiving it. I've worked alongside developers who are very passionate about their mobile platform. They love it. They live and breathe their Android or iOS. I wonder if they respond differently to bug requests around their workflows, especially around UI or perhaps one of the nuances related to the platform that they work on. I've been not part of, but I've witnessed various discussions pitting Android against iOS. So I suspect there's a cultural element for the developers working on it that comes into play.
I also think we could do something different. And I've done some research on this. It's usually how we have seen bug reports so far is you get a textual bug report, and then the developer reads it, try to reproduce the problem. And then if the developer is able to reproduce the problem, fix it, right? But something interesting would be to see if we are able to automatically translate these bug reports into test cases, and I've done work on that. What if we add a test case to the test suite without the developer knowing, and then runs the code and then sees a failure? Is the developer more prone to fix this issue or not? That could kind of, maybe because this this bug is coming from somebody, a user maybe is not paying much attention as a test that would be written by somebody at the company, is something that would be curious to see. And I think there is a lot of potential in the context of mobile, because it's very different how we interact with the software with respect to kind of traditional systems. We really, I think user can really express, there is a potential for user to express the type of interaction they have with the software in a way more detailed way than other types of software, because it's very interactive. And so it's really about how do we elicit this information and how do we present the information to the developer.
I wanted to ask a question around the issue that Christine raised around this equity, because it does concern me a lot. And I have worked on a couple of projects where lack of access to, say, a fairly high-end mobile device became a problem. The app just didn't run, or didn't run properly on older devices that some community members did have access to. And then sort of with our kind of trend, I'll call it, to sort of smart cities and smart living and so on, accessing government services, including at the moment, income relief and other such things, health, etc., through particularly mobile platforms.
It really worries. Also access to education.
Sorry?
Right now. I said to throw in also access to education right now. And that's a huge hurdle for a lot of people.
We've had some debacles here where we closed our schools and said, okay, everybody can do online learning. It turned out, particularly people in rural areas, where coverage, for example, is poor or even non-existent. So we live in not a very big state here in Australia, but big enough that it's not all covered, certainly not at high bandwidth. And then the cost, again, so, most of the people, if not all on this, are in relatively privileged or very privileged income positions where, the cost of a mobile plan is, not a huge inconvenience, but if you actually look at what they cost and you compare that to the sort of average income of families and so on, for a significant number of people, it's not cheap, or it's not an insignificant expenditure for their households. And if we move to an even heavier reliance on conducting, kind of living type services through those platforms, does this widen the digital divide? So I wondered, again, Christine, if you got any further comments there, or any other panelists or indeed audience members, any thoughts on, are we leaving people behind by the move to heavier reliance on mobile devices to conduct our everyday working, living, doing?
Yeah, I think we definitely are. With the new world and the more engaged, or more as the mobile apps become the command center for our cyber physical world, then there's going to be a learning barrier as well as to the economic nature of this problem. And touching on what you're saying about equity, Christine, is that we're going to find the use of machine learning and AI techniques more prevalent in this space. And mobile devices are rampant for data collection and aggregation, which is going to further perpetuate this issue. So we know that there's many apps in India that are from the Google platform, and they're on a lot of low-end devices, which is quite a different demographic and usage than what's used in, say, America or Australia, further exacerbating these issues.
So I was going to add like 2 anecdotes to this too, and that's kind of a cautionary tale. So one is with the app we've been developing for the university, we were very serious about privacy. So one of the things we do is we ask everybody who wants to come to campus to take a symptom survey every day. Based on the result of the symptom survey, the app computes kind of whether it's okay for you to come to campus or whether it's not okay for you to come to campus. And the app development team was very serious about, that's your business. We're going to tell you whether you should go to campus, but you make a decision about it. We're not telling your boss. We're not telling your professor. We're not telling anybody. We're telling you what to do. So that information isn't stored anywhere, right? But there was this problem that there are some people who need to access the university. They're usually much more in the service jobs at the university on campus who don't have access to smartphones. So a separate group was tasked to develop an app or an approach for them. And the way they did it was with touch-tone telephone. But what they did instead was they gave you this, they're going to give you the symptom survey over the phone, and you're going to enter all of your symptoms. And if you effectively fail the symptom survey, the way they had initially designed this approach was it would automatically email your supervisor. And so it's a way that this set of people who doesn't have access to a smartphone is actually being treated fundamentally differently than the set of people who have access to a cell phone. And I'm using those words carefully, the haves and the have-nots. And I thought, so we talked them out of it. We basically said, no, you should respond to them with a symptom survey that says, don't come to campus. And by the way, call your supervisor and tell them you're sick. But it's on them to do because we need to treat these 2 groups the same. Something similar has happened with a school district where we're working, where students who have Chromebooks of their own and internet access of their own at home are using them to access their digital resources or their digital learning. Students who don't are getting Chromebooks from the school district and also mobile hotspots from the school district, which is fantastic, except for these Chromebooks have a whole bunch of monitoring software on them. So this particular group of students is being heavily monitored, while the students who are able to provide their own Chromebooks are not being monitored in the same way. And so I feel like these are even like ways that we're trying to solve the problem, and our thoughts and hearts and minds are all in the right places, but we're still treating these 2 groups of people very differently. And that's something I think that has to bubble up into the software development teams. So that's my 2 quick.
Any other thoughts on this equity issue that's brought about by the increasing reliance on mobile solutions?
Yeah, I have a couple of comments about this, and it's related to the fragmentation of the ecosystem. In certain communities or in certain countries, there is a large use of low-end devices. And the unfortunate thing is that these low-end devices run either an older version of the operating system, or they don't get updated as often. And so they may be target of security attacks just because all the known exploits are available. And so that's inherently flawed the way in which the system is distributed to people. And there is no short-term solution for that. It's really up to us as a researcher on how to improve that.
So another issue that's been raised by a couple of panelists at least, again, and Mattia's again touched on it, is the ecosystem, particularly the sort of emergent one where Scott talked about, having to interface with a whole wide range of devices, but probably become a key point in that. So again, if you've got a smart home, the usual way of configuring that is your mobile phone. There's interesting questions, again, delving into privacy and security and so on. You've probably read about debacles where people's smart homes advertise that no one's there, so come and burglarize me and so on. But then again, as we move to sort of smart city type solutions, and probably a number of you are living in cities where a whole bunch of kind of interesting projects are going on to kind of provide sensing and interacting and so on. Some of that by a mobile device, or some of it by an app, if you like, a mobile app that happens to live in a kind of an IoT type solution rather than a phone type solution. Some of them that live in a wearable on your wrist rather than a sort of a conventional phone. These bring in a whole bunch of interesting issues, I think, for developing such apps, not just the equity issue again, but a huge compatibility issue. As soon as you upgrade one of these things, you've got a whole bunch of other ones that might be on different versions and different operating system versions and so on. So it fragments even more. And does that fragmentation increase exponentially almost as you introduce new devices to this ecosystem? Secondly, a lot of them again are energy sensitive, so there seems to be no end in sight. As soon as you make them more energy efficient, someone comes along with a great big machine learning algorithm and data storage we're going to stick on it that then now consumes all the resources we've freed up and a bit more. So they never seem to get ahead of the curve. And a lot of them, of course, by their very nature, either have to run on solar-based power or movement-based power or non-connected power sources. And then finally, interfacing to these things again, again, I mentioned the UX problem some of these COVID apps seem to have. One would have thought we could have solved that some years ago, but with wearables, with again, interactors, whether in a sort of smart living environment or similar, it seems to me that we've still got a long way to go to understand, particularly the range of users that you're going to have there, people with different physical and mental limitations perhaps to interact with those, people with different cultural and language backgrounds. There's an amazing number of these things only run in English. And yet Australia, like probably all of the countries you're living in, is extremely multilingual, multicultural, and we don't seem to still have very good ways of supporting that from a software development point of view for mobile apps. I wonder if anyone wanted to sort of comment on the challenge we have with these sort of emergent app ecosystems where it's not just to run on a phone, but on an incredibly wide range of devices, interconnect, and then support an incredibly wide range of users and uses. It's too hard.
No, I mean, I have a comment here, and it's about also what are the challenges of the future. So I think there is a challenge, but also opportunity. Google is developing a new operating system. It's called Google Fuchsia. And their vision for this operating system is one operating system for everything. So you have a laptop, it runs this operating system. You have a mobile phone, you have an IoT device. You have a home device, it runs the same operating system. And the reason why they can do this is because the operating system is highly customizable. And so how do we how do we develop software that is gonna run on such different devices? And that's a very interesting research question, which we should investigate. And should be this done within the operating system, or should this be done within the apps? So where do we put the burden? And so I just wanted to mention also, what do we do with the software we already created? How can we make everything being backward compatible?
Yeah, I think I'll expand on that one. I think that there's a trade-off here between what you're saying. It's a very interesting question to say, do these things go in the operating system or at the application level? Because we don't, I mean, it's great to have everything interfaced and all working, but building up a walled garden for a single organization usually doesn't seem to end well, right? We need to have a certain level of interpretability or flexibility for the end users not to be completely taken advantage of, to put it another way. And I think the fragmentation issue is going to be like increased because the opportunities for industry to own these new areas of integration with technology is big. So everyone's going to be trying to carve out their own little environment that they say, no, we control this little area. So the question of where the controls go in the software, I think, is a very important research question.
Sorry, go ahead.
Sorry, John. I just wanted to add one other thing to this, and I think there's a back to the use case, and you said about a flexible operating system. I think there's another research question about the use case that we investigate. So on one hand, we've got control, privacy and security at one end, which obviously we all desire and we all want. But at the other end, we also want to have usable systems, and we want to have systems that are open for research. And sometimes these four things sort of conflict and contradict each other. So how do we design software that allows the user to choose and adapt the range of these two spectrums for the applications that they're using?
I'll flag a couple of questions that have been asked. One is around this issue of testing, where we seem to have a lot of bug reports or user reviews that are essentially bug reporting and other channels. One issue is, are we doing enough testing in the domain, or we're allowing users to do a lot of the testing for us, and oh yeah, we'll just fix that the next iteration or whatever. And has this sort of become a part of our ecosystem as mobile app developers? Perhaps not a good one. And again, an equity issue, I guess, or to think about addressing that. Again, are there issues around, do we spend enough time backporting or backpatching, or making sure that previous platforms we might have been running things on that a lot of people are still using and might be using for a long time, the version of the software can still effectively run, and that might be releasing multiple versions as you release, rather than just a single updated one that now only runs on the latest versions. And other issues around, again, say thinking about this sort of resource consumption, particularly with older devices where they often suffer from major problems. Do we need to think about more carefully about, again, the ML models is one issue that's been raised, that will work on older devices rather than assume you've got to buy the latest Android or iPhone platform to be able to effectively run them on. The first one I wondered, Pik, did you have any thoughts on this kind of quality assurance in the mobile app area? We got a bit slack and we just decided we can chuck something out there, someone will give us some reviews, we can fix it real quick. Do we sort of cut a few corners in delivery, and is this a current challenge we really ought to think more carefully about now and in the future?
Yeah, I think I actually agree with David in the chat here that we should encourage the industry to test the mobile apps before pushing to the users, because as a user, if I encounter many bugs or many issues, I tend to uninstall and don't want to use this app anymore. So I think the industry should be like have to ensure that the apps is ready to release. And so as we know that we have a defect prediction model to help us to at least ensure that it's ready or not. But as I said, the key challenge is it's very hard to build a prediction model because we don't have a bug, like a concrete bug report, and it's very hard to get the data and build that to build a model to have an accurate prediction. Yeah.
I guess our ecosystem at the moment allows you to deploy an app that's pretty, poor in terms of quality with very limited checking of that. There's some checking about signage and other basic features, but there isn't, you don't have the evidence to say the App Store. I've run a comprehensive testing program. I've got a bunch of comprehensive test cases. I've tried a defect prediction model on this app, either dynamic or static data or both. And, there's a high degree of confidence that, its quality is high. We have almost the opposite, where you can push out things that have got a number of problems, and again, it's really users that end up having to flag them.
So there's an undercurrent to both these questions, and actually to Pik's response too, and that actually ties them all together, which is that we allow the market to decide what we fix, and we allow the market to decide what we build. And with that, I mean, that's the driving force, right? So if you have a bug that's expensive to fix, but only happens in devices that are 5 or 6 years old, there's no incentive really to fix it, versus a bug that every single user is going to experience, and they'll experience it within 30 seconds of using your app. You got to get rid of that one. Otherwise, you literally have no market. right? And so I don't have an answer for that. It's just an observation that, you know, it is the way the market works, that in order to succeed, to get your app to be successful, you have to please the majority. And if you spend too long trying to please the minority, then you're going to be beat to market. Like, you're not even going to have any app left to distribute. So it's a kind of fundamental market incentives problem, I think. I'm not an economist, but I feel like.
Well, I guess that also addresses question 2 a little bit in terms of, you know, Scott, I'll flag it to you as a developer. You know, would you have liked to release 3 versions, 4 versions, 5 versions of every release that are shown to be back compatible or forward compatible, etc.? You know, doesn't that unreasonably increase, you know, the challenges for the development community? So that, again, to Christine's point, you know, we're going to try and satisfy the majority to maintain our market, grow our market. If we lose some people along the way, that's just how it is. If they happen to be the less fortunate in society because they've got older phones or whatever, well, you know, that's how it is. Is it sort of market economics that's kind of, you know, leading us in that way?
Yeah, I think it is partly market economics, but it's also partly the nature of the ecosystems that produce these platforms. So there's many, like, one of the things that I really struggled with these challenges that we've been talking about today is that these are not, a lot of these aren't all brand new, right? When we started back with the early versions of iPhones and Androids, these issues were all starting to be discovered, and in various forms or nature they were there. And one of the things that we thought we could deal with it was reuse some solid software engineering principles like model-driven development. And we've made a huge advances in model-driven development, but still, when I walk around engineering shops, the first tools that people merge to are not model-driven approaches. So there's this element of the ecosystem that's pushing out these new versions and these new modifications, which require developers to have maintenance effort as well. So you've got the market pressure from what people want to buy and sell and what the users are saying, and then what's being forced on you by changing permissions and the ecosystems themselves, or the platform vendors, perhaps, is the better way to put it.
So Leopoldo has made a very interesting comment. Those of us who are educators, again, you know, we do have probably, I would argue, a responsibility, but also, of course, the opportunity to flag a number of these issues, particularly again around the equity issue. So he raises the issue of the Brazilian context, where there's a lot of phones, but you know, a lot of them are at the low end, or again, might be older or less capable, if you like, than the latest and greatest. How do we put that front of mind of our students that we have the opportunity to shape the future practitioners, so that they might take some forethought into some of these issues? And again, I don't know if anyone who's teaching mobile software development consciously does that in any of their units where they do flag that we're not just designing for the very latest, most capable, latest version of the operating system, hardware, etc. But there's actually a very diverse user base out there. Again, sometimes I think we forget that we might be fortunate to have access to all those latest and greatest technologies and things, but that is not necessarily the case for a large segment of society. We might go on to, sorry, go ahead, Christine.
No, I was just gonna, so another observation there is that this is actually at odds with the fact that we are, or many of us are, mobile software engineering researchers. And it's kind of our job to be doing research at the forefront, right? And so it is our job to look 5-10 years out at what the capabilities are going to be, not what the capabilities were. So there's kind of like this disconnect between kind of a social obligation and job, like what my job is, right, as a researcher in this space. I don't know. That's, again, I'm just here to say make random observations, not offer.
Oh, it's a great observation. And again, I guess part of the research, of course, can be better understanding the wider usage scenarios, users, etc. And again, you know, how do you support those as well as the latest and greatest, what we can do with emergent and creating new emergent mobile technologies. And
this comment might be a bit controversial, but it's also what researchers find interesting. there's a certain class of problems that engineers are always faced with that just aren't motivating to people who spend their time doing research. I mean,
and would MobileSoft accept a paper, dare I say, on, for example, backwards supporting, less able platforms? So the 3-year-old platforms that might still be out there that a number of users have, would someone get a paper in on techniques to better support that? I would hope the answer would be yes, but I don't know if there's anyone seen one of those in recent years. Maybe this panel might motivate people to think about there's an opportunity. David, you'd be open to such a paper being submitted, and if the referees were happy with it, published and presented at MobileSoft, wouldn't you?
Yeah, certainly. I think I very much supportive. Actually, I'm also working on backporting, and sometimes I get comments from well-meaning reviewers like, why are we still concerned about this apps that only 2% of the people care about? But I think we need to care about this 2% as well. Yes. Yeah,
well, it's pretty important to that 2%. If the only way they can access education, government service, health service, etc., is pretty important.
I would also challenge that 2%. I mean, the world's a big place, and there's many different markets and in communities out there. To say a rampant statement of 2% is very hard to back up, I would argue.
Indeed. We'll move on to the sort of second panelist statements and discussion, which is the future challenges. So we asked the panelists to think of what is their top future challenge for mobile software engineering, and maybe just a few brief thoughts of how we might get there. I'll start this time with Mattia. Your top challenge, future challenge, and yeah, brief thoughts how we might get there.
Yeah, so I mentioned briefly what was the top challenge for the future for me. It's this new era of mobile operating system, and what type of, how we are gonna develop research tools for mobile applications so that they can support this new class of operating system. And what I mentioned before, there is this new emerging class which you can highly customize the operating system so that you're able to run it on different platforms. So this interplay between how the development will be of mobile software, given that you might not know on which type of operating system you are gonna run the software.
That's a tough
challenge. How we are gonna go there, and I think the first step is to think, as I mentioned also a little bit earlier, is should we design, so should we worry this at mobile app development time, or should we try to do research on the OS side so that we don't need to think this at development time? And I think there are trade-offs on doing on either side.
Excellent. Pick key future challenge. How are we going to get there?
So I think, first of all, I think nowadays the next generation of the mobile app will be the AI embedded mobile apps. So the question is that how can we assure the quality of that kind of mobile apps in terms of the accuracy of the AI model and the performance, energy consumption? How can we know that the AI that we embedded in the app will not consume lots of battery from the users? And yeah, this kind of thing that we should concern for the next generation of the mobile apps. Yeah.
Excellent. And Scott.
All right, my top challenge is sort of a merge of the previous two, but I'm thinking of how do we define a cyber physical world and make appropriate trade-offs between the privacy and security on one hand, and then progress and usability on the other. So as the world gets more connected, I see more of these issues coming to the forefront and manifesting itself in different ways. And I think the way to get there is to sort of try and build systems that guide and support the engineers in constructing these new world. So give them the AI and the intelligent decision support to make informed trade-offs, to understand the nuances in the architectures that they're building, to deal with whether they're going to make it adaptable or what issues are going to be raised from the knowledge that we've got already about the mobile and IoT systems.
Excellent. And finally, Christine.
Well, I swear I wrote down an answer to this question before we had this whole long extended conversation. But what I wrote was kind of taking ownership of social accountability and balancing kind of innovation with the social responsibility and avoiding innovating faster than what I wrote was, I swear to God, I wrote this all down, innovating faster than is necessary or arguably ethical or appropriate. So it's just kind of this balance we've been talking about actually for the last 20 minutes or so.
How do we get there? How do we solve?
Oh,
Any thoughts?
how do we get there?
Yeah.
I have no idea. That wasn't one part of the
that was the last part of the double barrel question. But don't worry, we
like
don't
my
have to have a
students,
solution.
I only read the first part. Oh man.
Think about that and come back to me.
If somebody else go first.
Our chair has asked a great question again, which is the bias in AI1. So you've undoubtedly all read a number of articles around the shocking amounts of bias in AI-based solutions. Mobile-based ones is no different, and some might argue they could potentially be worse than others, depending on, if the app tells you, blah, 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 and it's something that, you're using to, again, inform your education, health, workplace activities, social activity, and so on. There's all manner of potential bad things that can happen. Again, it's become front of mind, I think, to people that again, does it make the problem of equity worse? It most certainly does. How might we deal with it from a testing perspective? But maybe I'll suggest more generally an engineering perspective in the mobile app landscape. Anyone got any thoughts on biased mobile apps that have biased AI in them and the problems they cause us?
Yeah, this problem is very interesting to me, working in an AI institute. I think one of the issues related to this is that data is inherently the motivation behind this. We have bias because someone trained a model on data that was inherently biased through some mechanism. And we just, as a community, the software engineering community, don't have the tools or the techniques to be able to deal with these problems at all stages of the development lifecycle. So some of the research that we've been doing is around the differences just between the integration of a data scientist and a software engineer. There's already a bunch of assumptions that are done at the model time that get lost as soon as that model goes from a data scientist to a software engineer. And the engineers are the ones that build the world. So we need techniques to be able to intelligently determine what data is coming in, how it's being used, and what are the underlying biases. And not just the bias itself, but also how the data changes. So it's not like it's biased this way and it's forever biased that way. It may change based on how it's trained, how it's learned. And we just don't have the systems that detect, monitor, analyze, surface this in an engineering context.
Any other panel member or audience member got a comment on that?
So there's also, there's a lot of work in and it's been mentioned before about kind of pushing this learning to the edge devices, to the end devices, making it lightweight, federated learning, all of this, these techniques. And I worry, I don't know a ton about this space, but I worry that you get into these same kind of things you see in like social networks where you're self-reinforcing what you already know, right? So it's like overtraining models become an even bigger, like this biases get amplified because of the way the mobile systems are built. So I think I'm kind of reiterating what Scott was saying, which is we don't understand them. And so we basically abuse or misuse, let's say, the models from kind of the data science understanding.
And there's many related problems to that too. We've talked about bug reports. So how do you write a bug report for bias? The end users may not know, right? So you might get 4 bug reports from 5 different communities, like people from 5 different communities that tell you different things about the way the model's performing. What is the bug fix and how do you replicate that when it's inherently based on data that it's been trained on, data that's come in,
distributed, yeah,
and the model itself.
Yeah.
And when you've got a distributed thing, you don't even have the provenance chains to be able to reconstruct the process of how it was done in many cases. And now we're going to take that problem, which is a very known or starting to become a very well-known application, and now we're going to split it into a distributed computing environment, which is complex, And then we're going to distribute it even further to say it's not in our data center. It's now across 100 devices in someone's home, across a community. How do we remotely monitor and inspect? We won't even know if it's happened for a first. And then we have to try and capture the data to be able to replicate this in a nice little desktop environment where the developer's located. Many challenges here.
And there'll be so many examples of denying that there's a problem in the first place too, right? My model's great. What are you talking about? Right?
You can't prove it.
Yeah.
It's a black box in many cases. And even if it's not a black box, how do you replicate it based on the data, right? Because you might be continuously training the model once a week.
And the data may be kept private on purpose because it's super personal or for whatever reason. Yeah.
And this, I mean, every stage, it's also interesting too, because the different people, the people who create the model, support the system, build the surrounding infrastructure, and answer the support calls, maybe 4 different people with 4 different skills in statistics, engineering, data science, user-facing, client management. And the information is going to be vastly different on what the person needs to fix their part of the problem. And like the data scientist gets the data and trains a model and says, okay, look, my model has mathematically proven, here's the evidence, here's a mathematical proof. The engineer gets it, feeds in input, gets the output and says, the format's the same, the structure's the same, the problem's not with me.
Yeah.
The DevOps person says, look, it's deploying and it's being run into production, the version's new, it's not with me. And the client's saying, I got discriminated against, I couldn't get a fraud check.
Any thoughts from a software point of view, a quality assurance point of view? I mean, it's an interesting intersection Scott's flagged. I think, you know, we've got data scientists, and again, a lot of us are educating them. They're not software engineers. There's a little bit of overlap, but I might argue maybe not enough. And software engineers are not data scientists, even though we might, you know, build our machine learning models and so on. It's interesting how many software engineers know how those machine learning models work under the hood. You know, how you actually go about getting a proper, unbiased or representative data set for those. Can you even repeat the experiments with those models? Any thoughts about, you know, how we tackle this as we kind of add all this kind of AI, if you like, this machine learning based capabilities to mobile platforms that perhaps arguably we as software engineers don't really fully understand?
So I just want to have some thought around this. What I'm thinking is that, so on one hand, we want to have AI or mobile apps to be usable for a wide range of the users, including majority and minorities. And we want to make an AI model to be accurate for everyone. But on the other hand, many people are concerned about the privacy and the data. So like some group of people might not like willing to share their data. And then how can we build the model or the mobile application for that group of people? Like, it's like we want the data to make the mobile app for everyone, but not everyone willing to share the data. So to me, I feel like it's very trade-off and it's very challenging to achieve this goal for the equity. Yeah.
And David's raised that exact question in one of his posts. You know, again, we've got essentially a kind of conundrum. You need more data to do more accurate training, but by providing that data, you may run into, or very quickly run into, various kind of privacy issues. So that there is a problem. I'm just flicking through a couple of questions. I'm not taking them in the order they're coming in, so apologies to the askers. But one I think an interesting one we've touched on is the IoT sort of development problem, where an interesting one is as an IoT, if an IoT thing's mobile, is it a mobile app? And secondly, again, we've got all these kind of smart homes and smart living things that have become kind of all the rage, it seems, with a whole manner of different devices that you might connect to and control with an app. How might we go about engineering these? What challenges might exist in the IoT domain that overlaps perhaps significantly or perhaps not with the mobile app engineering domain. I wonder if anyone had any thoughts about that.
Yeah, I can start, and I think this is a great question, and I can maybe rephrase it in such a way that sounds like, why didn't we do much research on iOS and we have done a lot of research on Android? And I think here there is a common issue, is that the infrastructure on which our research build upon is not present. And in the case of iOS devices, I think it's different from the reason of the IoT devices. And in the IoT world, I think the heterogeneity of software, it's a big problem because we don't have the tool to analyze this type of software yet. And if I want to do an investment and I say, okay, I want to build a tool to analyze this type of device, then thousands of other devices come up, and the analysis cannot support these devices. And just to give you an idea, I recently talked with some researchers, and they were doing fuzzing of IoT devices, and they were doing this through the web interface, because that was a common interface that some of these IoT devices had. But of course, then through the web interface, you can ask portion of the software, but and so you will need to have more direct access to find even more problems with the software. So I think the infrastructure is the first step that probably some researchers could focus on. And I hope, so I don't know, it's a very big question.
So something I think that could be shared, so I think that's kind of the question, is what can we kind of take from software engineering for mobile apps to software engineering for like IoT? And I think Scott was the one who used the word provenance. Like, one of the things we don't have now a lot of the times is kind of an understanding of the situation in which a bug happened. I think the same is, and they're often not replicable, right? I think the same also happens in an IoT context. It's really hard to describe why my smart home or my smart city didn't behave the way I expected. I might not even be able to put it into words. I can just say that something wasn't right. Something didn't happen the way I expected. And so I think that's a thing that's shared, is how do we better elicit the content of a bug report, right? What does it mean for the system to be wrong? And what does it mean for it to be correct, so that we can generate tests and fix things? I think that's a thing that may be shared between the two.
I think from the problems that from the IoT world, from the mobile, is that every problem that you've got on the mobile is amplified in the IoT space. So let's take the usability problems, right? Okay, sure. John's app crashed multiple times. How do you write a bug report for, I asked the fridge to open 10 times and it didn't understand my French accent? That's the kind of device in the IoT. We talk about sensor integration with the mobile apps. So there's a range of sensors. Now, often with IoT, you've got to get the hardware designed. So now you've got to deal with the whole messy world, which is electronic circuit board design. So many of the applications and issues that you have may be at the hardware level, and your software may be functioning 100% according to spec. And now you've got to have now go back to the testing. So testing's hard with mobile, but now you've got this dichotomy between hardware design and the software functionality, which may only function in certain scenarios which you can't replicate. And augmenting and putting a debugger on hardware is a whole new kettle of fish than just connecting a tool to my IDE and just watching the logs.
I think it's a great observation. So in a couple of smart living projects I've been involved with, again, every deployment's different. So they'll have different versions, different brand of light bulbs, which supposedly have the same interface, but actually it's not, or they don't behave under the hood exactly the same. They get upgraded every now and then. Which the light bulbs in my bedroom and my lounge both upgraded to the latest version. I was one while running an earlier one which has got deprecated features which I have to backwards support, and then I go to my next door neighbour who's now got another version, etc. And then you add different devices, it compounds and compounds. So I think that's actually a really, really, really difficult and really challenging software engineering space that we've only barely touched on. I had to present a tool demo paper at ASE last year, and it was a sort of edge computing, fog computing thing. Almost nobody at ASE knew what fog computing was or edge computing was. And when I said IoT, only vaguely had an idea what IoT was. And my feeling as a software engineering community, we haven't really caught up with a lot of the issues that Scott's just outlined. And we've got a very long way to go to provide, you know, really good, solid software engineering support for IoT solutions. And again, I agree that I think it actually exacerbates many of the challenges faced on mobile apps. And I think mobile apps are a lot harder than web apps. So again, we had a challenge when we got these kind of distributed client-server web apps 20 years ago, or whatever it was. Mobile apps are a lot harder again, and I think IoT is a lot harder again. And yet, as I outlined at the very start of this panel, we still seem to have a lot of challenges even developing a half-decent app for, you know, pandemic support type things that we're faced with right now. Now, the really interesting one has been asked by our virtualization team coordinator, Rahul. Well, what about using a cloud clone approach? So don't run everything on the IoT, the wearable, the phone, etc., but run it on a sort of cloud-based and have just a very, you know, kind of emulator type support on the hardware that abstracts you away from particular versions and so on. I wonder if panel members had any thought about something like that, which might tackle not just the equity issue. So the thing would run the same on the cloud, and therefore, you know, so long as the emulator works on the device, you've got your supports, and potentially could that address some of these IoT issues as well?
I think this is an excellent idea. I think kind of in the limit, the idea is I just carry a radio and I somehow farm all of the other resources that I need for everything from things that are available around me, right? Like I somehow assemble my app literally on the fly based on the stuff I can connect to. Maybe I carry a screen, maybe I don't. Maybe there's enough screens kind of embedded in various places. It's interesting because it's kind of the way Chromebooks have gone, right? Like, you know, 5-10 years ago, everybody had super powerful MacBooks. Now a Chromebook is really, I mean, think about the things you did today. If you take out kind of your actual like software development stuff, I mean, most of the things you do can be supported by a pretty dumb terminal to the cloud. I think it's an excellent approach for whole. An excellent idea. Sorry.
Except backgrounds in Zoom.
Yeah, well, come on, man. It's actually a Mac Mini. So I don't know what its problem is.
Yeah, so it's to some extent, I think there is a line of research that worries about transferring computation from mobile devices into the cloud. And I see this as kind of being a similar problem. And I think one of the main challenges is how do you do the transferring of information in an efficient way? And the other way, you still need to have computation on certain devices because they do sensing for you. So how much of this sensing is tied to the computation, and how you do efficiently this transfer is one of the challenges. And for example, for these, let's say for some of the devices you just deploy in the field and you don't have any access to them, I don't see how this communication can happen, as the battery will die very soon and it might be very expensive to retrieve this type of devices. And so there is, maybe there are some domains where this type of approach is more applicable than others. And it will be an interesting research direction to see which type of domains this is more applicable.
You're right, we need energy to be free, or else we have to wear like belts that are battery packs or something as we do all of our moving around.
From the audience, any sort of comments on future challenges that either we've missed, glaring omissions, dare I say, ways we might address some of the ones that we've identified but perhaps haven't, or there's alternative ways of doing that, or any other questions or commentary for the panel? Feel free to type or unmute and say something. Any are welcome. All good then. So we might just have a last last statement from the panel members going around. So we identified a number of current challenges of mobile software engineering. They're a little bit different to last year's. So again, I have the privilege of having attended both panels. While there's a little bit of overlap, there's actually a lot less overlap than perhaps I actually initially expected, which is both interesting and I guess good. But all our future challenges still seem to be future challenges. We identified a couple of these last year as well, and I'm not sure we've advanced any of them actually, much to my knowledge in the last year. I could of course be wrong, and that wouldn't be the first time by any means. But again, I might just go through each panel member and just ask any final thoughts that you have about where we're at and where we're going to. I'll put Mattia on the spot first for that.
Yeah, I feel there are, as we discussed today, there are topics which we believe are essential to be taken care of, and these the good thing as a researcher is that these topics are pretty, they are different in nature. So we saw some topics like the fragmentation of the ecosystem, but also some AI related problems. So I also see opportunities for the mobile community to have some synergies with other researchers from other domains. And so I think as a message, I think we should not be afraid to try to see and collaborate with people from other domains to get our own research community work toward the better good of everything.
Great. Christine, you can go next. Any final thoughts for the audience and the other panel?
Yeah, sure. So I am actually really energized by, so the other hat I wear is kind of the pervasive computing hat. I'm really energized by how much of this conversation was not about how I use the screen or how I use the physical mobile device. We talked about UX, but we talked a lot about interacting with the spaces that we inhabit. And I'm just excited to see us move away from, you know, hurting our necks by staring at screens and trying to think about how mobile computing allows, or mobile software engineering allows us to interact with the world around us rather than the device we're carrying. So that's what I'm taking away.
Excellent. And Scott?
I think along with looking for collaboration to solve many of the problems, because many of the issues that we spoke about today are quite diverse, right? It might be a software engineering problem, but to solve it adequately, it will require talking or working with experts in different fields and that. So while we do that, I think it's important that we also think around the context in which the research and the solutions that we're proposing are most optimal, especially considering the diverse range of problems that are present there. And just another maybe plug for the use of decision support and AI systems, perhaps look at using that technology rather than to just find more data and to predict various things. Maybe it can be an assistance tool to guide and support the engineers as they face this very challenging emerging world.
Absolutely. And Pick?
Yeah, so I think the discussion today is around the issues with the users in various aspects, like different kind of the user, different kind of the mobile or the platforms. So I think we are in the right direction that we focus on the users, because the mobile app becomes like a part of our life, and the quality of the mobile apps has like very direct impact on the users rather than the other kinds of the software. So I think that the last message is any kind of a problem that we want to address, it should help or it should impact the users. Yeah.
Great, thank you for that. Last chance for any comments from any other audience members. David, you've got to have one surely. Maybe not.
I think that today's panel is very interesting. I think we discussed a lot of issues, I think, with open-ended questions, right, from privacy to environment to testing and also to equity. And I think it's a very exciting panel that we have this year. And yeah, yes.
Excellent. And so I just want to finish by, well, first of all, thank you all for coming along. But I think it would be great to see a few of these issues, future issues, tackled in MOBILESoft next year or later. So, for example, I think the equity issue is one that we touched on quite a number of times and has a whole lot of really multifaceted aspects. I think that would be a great line of research for this community. We talked about the backwards compatible, the sort of cloud clone, the sort of, you know, thin interface and then offloading and so on, which of course, not just for mobile, it could work for other small devices and so on. So I think that's a very potentially fruitful line of research. Could tackle a whole lot of interesting issues that the mobile software development community has. We talk about IoT, and I'd like to suggest to people that mobile apps aren't just things that run on one of these. This is my iPhone. You can't quite see it there. But I don't have my wearable on, but on my wearable, there's lots of apps on those. I might be carrying, again, another kind of wearable on my body that is a mobile app that might be monitoring health things or doing other kinds of you know, monitoring to support my lifestyle. Dare I say, as I drive my car around, my car's got a bunch of apps in it now that I can install. And I shouldn't be using them probably while I'm driving, but you know, it does various things for me. And the latest vehicles, if you're not aware of it, you could download a whole pile of apps, and they even call them apps, and install them that give you a better music player and other kinds of stuff. As I guess smart living solutions become more prevalent, you know, what's the difference between what runs on my phone as an app, something I install on my smart TV, my smart fridge? So Scott could download it. I can't remember which the language was he used that the fridge couldn't understand. But I could download that language support for my fridge so it can actually understand me. I can download the New Zealander who's lived in Australia for 10 years accent understanding plug-in for my fridge so it might actually understand me. Yeah, I guess those smart living environments get there'll be a whole lot of inverted quotes apps, mobile or otherwise, that probably have very, very similar issues to the range of ones that we've been talking about today. And I'd like to suggest maybe some of those might well be in scope for MOBILESoft going into the future. So I just want to finish now by thanking the panel for your time today and provoking some really interesting discussion and ideas. Thank our virtual support persons / people for, again, making the virtual MOBILESoft run and be a success. Again, the audience for their time, and again, particularly if you joined at some horrendous time for wherever you happen to be living. We do have more going on today. So the next time zone, what's the time zone called? I'm not sure which it is, but it says 5 o'clock Melbourne to 5 p.m. Melbourne time. Which is that time zone, David?
It's the Indian time zone, I think. The
Indian
next one.
time. Okay, there you go. So we have energy consumption, which again we've talked about today, and followed by that we have at 11:30 tonight my time to 1 a.m. my time. So I'm probably not going to join that one. Security and privacy, which again we've talked about today, and then finally a closing session. I'm sure David will.
It's the
2 a.m. So if you don't see a John Grundy on at 2 a.m. this morning, tomorrow morning, David, I hope you'll forgive me, but I may be asleep at this stage. So again, I want to thank you. Running a panel virtually is kind of an interesting experience. And again, thank you for your time and enjoy the rest of MOBILESoft 2020.
Thank you very much, John, for being the moderator and all the panelists and attendees today. Thank you very much. Yes.
Thank you all very much. Have a good rest of the day. Take care. All the best. I hope to see you next year in person at MOBILESoft 2021.
That's right. Thank you very much. Yes. See you next year in person. Yes. And next session.
Thanks. See you. Bye-bye.